Hi, this video is going to cover 4 theorems, 2 concerning addition and 2 concerning subtraction. What could be easier? These were practically axioms for Euclid, but for us, they're going to be essential building blocks that we're going to want to put in conditional form and use in several of our proofs in the coming chapter. So we'll talk about 2 theorems involving addition, where we add 1 segment to 2 congruent segments, and then 2 segments to 2 congruent segments. We'll do the same thing with subtraction, where we'll subtract a congruent segment from 2 bigger ones, and then subtract 2 congruent segments from 2 bigger segments. I know it sounds really confusing, but when we get some pictures in front of you, I think it'll help. So enjoy the video, and I hope it does help. We can handle addition and subtraction on the same diagram. We'll take them one at a time. So let's take addition first. Suppose we had a segment, AD, that was broken up by BC. Now, B and C are nothing special. They're not trisection points or anything like that. In fact, we can change the length of this all we want. But what we're given is that AB is congruent to CD. What conclusions can you draw? Take a second, hit the pause button, and see, looking at this diagram, if you can draw any conclusions. Okay, hopefully you saw that if you added this segment, the blue segment in the middle, BC, to each one of these congruent segments, the sum would be congruent. And that becomes our first theorem. If AB is congruent to CD, then AC, the larger segment, is congruent to BD, the larger segment. And the reason is, if a segment, it's in blue to color code it with this segment, that blue segment, is added to 2 congruent segments, the orange ones, then the sums are congruent. Okay, let's take a look at subtraction now. With subtraction, we start out with the opposite givens, and we make the opposite conclusion from addition. Here, we're told that the longer segment, AC, is congruent to the longer segment, BD. Given this diagram, what conclusions can you draw? Hit the pause button on the video and see if you can come up with one conclusion. Okay, hopefully you saw that if you know AC is congruent to BD, then you can conclude the smaller orange segments must also be congruent. And that's the opposite of what we just saw in the addition theorem. The reason for subtraction is that if a segment is subtracted from 2 congruent segments, then the differences are congruent. Notice here that the segment being subtracted is BC. The 2 congruent segments are the long ones, AC and BD, and the differences are AB and CD. Let's take a look and notice how subtraction has the givens, which were the conclusion of addition. It's really hard to draw with this mouse. And the conclusion of subtraction was the addition givens. All right, so one quick little summary. How do you know to use what? Well, whenever you're moving from a smaller quantity, like A, B, and CD, to a greater one, like AC, we use addition. And you can see that when we add these 2 segments together, we get the longer segment, AC, and a longer segment, BD. Whereas with subtraction, we start off with a given that is greater than what we're trying to prove, and we move from greater to smaller. Okay, I hope that helps. We're going to take a look at 2 other cases of addition and subtraction that involve 4 different items. Here we just had 3 segments or angles, and there we're going to look at 4 segments or angles. We also talk about subtraction and addition when talking about angles. Let's look at an example here that's very analogous to the last 2 theorems we learned on addition and subtraction for segments. Trying to come up with some conclusions with the following given information. come up with one conclusion if you know that angle ABC is congruent to angle DBE. And then pause the video while you come up with a conclusion if you know angle ABD, the larger angle, is congruent to angle CBE, the larger angle. Okay, go ahead and pause it and come up with a conclusion for each. Okay, hopefully your first conclusion was that angle ABD, this larger angle, was congruent to angle CBE, this larger angle. Because when we add angle CBD in the middle, it's adding the same angle to two congruent angles. And for the second given, we can see that the smaller angles ABC would be congruent to DBE if you subtract this middle angle CBD from both. So add these two theorems to the addition and subtraction theorems we had for segments. Make sure you're keeping up with making flashcards. Alright, now let's take a look at two more theorems. Okay, suppose we were given two segments that were not connected in any way, but we knew they were congruent. And we added two other segments, like BC and YZ, that we also knew were congruent. What conclusion could you draw? Well, I've mapped it out here for you, and it's pretty easy to see that if we add AB and BC and add X, Y, and YZ, the sums are congruent. And that's the next theorem. So our given information is that these two pairs of segments are congruent, and that when they are added, the sums are congruent. So pay attention to the color coding. If congruent segments are added to congruent segments, then the sums are congruent. Does it work the other way? Let's take a look. If we were to be given that AC, the long segment, was congruent to XZ, the long segment, and we were to subtract the congruent segments BC and YZ, or the red segments, it stands to reason that the blue segments would also be congruent. And that theorem is called subtraction of congruent segments. So if we were given that AC is congruent to XZ, BC to YZ, we can conclude that the blue segments are congruent. So if congruent segments are subtracted from congruent segments, then the differences are congruent. Just as we looked at an angle example when we were discussing the addition and subtraction of the same segment or angle, we do need to look at an angle example when talking about adding or subtracting congruent angles. So let's say you were given this information, that angle ABD was congruent to angle WXZ and DBC was congruent to angle ZXY. What conclusion could you draw? Take a minute and pause the video until you come up with a conclusion. Also, if you were given that the large angle ABC was congruent to the large angle WXY and the smaller parts DBC were congruent to the smaller part ZXY, what conclusion could you draw there? Now pause the video and come up with a conclusion for each one of the given statements. Okay, hopefully your first conclusion was that this larger angle was the ABC was congruent to the larger angle below WXY. That's because if congruent angles are added to congruent angles, then the sums are congruent. For the second given, we could show that angle ABD, the smaller angle at the top, was congruent to angle WXZ, the smaller angle at the bottom. Because if congruent angles are subtracted from congruent angles, then the differences are congruent. As you can see, just as before, when we're going from a larger angle and we want to prove a smaller one, we use subtraction, as we are here. But if we're given the smaller angles like ABD and WXZ, and we're wanting to prove a larger one like ABC congruent to WXY, we use addition there. Okay, I hope this helps. We have a lot of theorems, so please be making cards and memorizing as we move along the way. Okay, that was a lot of theorems. In total, between segments and angles, addition and subtraction, you got a total of 8. So I can't urge you enough. I know I've said it a lot during this video. Make some flashcards. Get these things memorized. Putting them on a piece of paper isn't going to do what you really need to do. You need to find some index cards and draw a picture, just like I have in the videos, with the given information on one side, and on the other side you put the conclusion and the reason, which is of course the theorem or the definition as we saw in some of the earlier chapters. Please get on this or else the stuff will start getting away from you. We're going to start picking up multiplication and division in the next video, so you can see we'll probably have another 6 or 8 there as well. Okay, hope everything's going well. I hope this video helped, and we'll see you tomorrow in class.